Okay, so welcome to TechTalks, our regular podcast on technical issues that come to us through our technical services department. It's a brand new format here. The first bunch of them were just audio only, so we're trying a new video format for this particular one. And once again, here with Shaun Kramer, our manager of technical services. And today, our Tech Talks is going to circle around the concept or the subject of flow control systems and the top 10 questions we get on those particular systems. So, Shaun, to start off with then, just going with the regular format that we've had all along, fire away with one of these questions here. Why are Viking flow control systems only offered with an electric release? And so I've got a technical data sheet here for the Model J flow control valve is what it's called, and it's showing, on this one it shows hydraulic and pneumatic releases. So why does the system? What's the difference, and why does the system one have only offered with an electric release?
Well, with the valve data sheet, the J1 flow control valve, it's used on multiple different types of systems.
Oh, okay.
So here we're talking about a flow control system, and the valve could be used in pressure regulating deluge systems, where anytime you have pressure regulation, you're going to be using a flow control valve still.
Okay.
And you could have a pressure regulating deluge with hydraulic, pneumatic, or electric release.
Okay.
But when we're solely talking about the flow control system itself, it's going to be electric release only.
Okay. So it all depends on configuration and system it's being used in.
Yes, exactly.
Great.
Yep.
All right, so next question then becomes, is why do Viking flow control valves have a spring installed between the cover and the clapper?
Well, with the flow control valve, the spring that's used in there, that helps to shut down the valve. So a lot of these systems, the focus of this flow control system is to be able to shut it down from a remote location just by flipping a switch or hitting a button to cut off the power to the solenoid valve.
Okay.
So when we start to reestablish the water in the priming chamber and you have the flow coming through the valve through the inlet, you need a little bit of assistance to be able to push that clapper back down, and the spring provides that assistance to push it back down on the seat and not allow any water to flow through the system and close the valve.
So if I had a deluge valve, couldn't I just put a spring in it and call it a flow control valve?
No, that wouldn't work for the fact that it's part of the listing of the valve.
Oh, okay.
So per the listing of the valve, it's listed as a flow control valve.
Oh, all right.
So, and our deluge valves are listed as deluge valves. So based upon that, as well as the labeling of the valve on the cover, because the deluge valve says deluge valve, flow control valve says flow control valve.
Sure.
So even though it might logically sound like it could possibly work, it wouldn't be something you would ever do.
Okay. So next question then is, should I close the priming valve on the 1/4-inch priming line for the Viking flow control valve after it has been put into service? So am I closing that valve when I'm done with the installation?
We always want to leave the priming valve open. A big part of this is a lot of the water supplies are fluctuating water supplies that we're dealing with.
Okay.
So anytime the water supply fluctuates, if you have the priming valve closed, you're not going to get that pressure in the priming chamber. And the valve has a 2-to-1 differential, but if you get a high enough pressure fluctuation, that could cause the valve to possibly not stay closed if that were to happen if you have too high of a spike of pressure in your water supply. So by leaving the priming valve open, it's going to allow that higher pressure to go up into the priming chamber as well of the valve to compensate for the changes in the water pressure that's coming into the inlet. Another thing that it will do as well by checking that pressure into there, you can see where the prime pressure is a little bit higher than the inlet. That's very common to see, and it's not a concern as long as you're not exceeding the 250 psi rating of the valve. So it's very common to walk in, see your prime pressure at 100 psi and your inlet pressure at say 80 psi, where you have that difference because at some time it spiked up to 100 psi, but currently you're seeing it at the 80.
Right, it's settled back down. So we're not, it's normal, it's not a concern unless you get way up, into the 250 range.
Right, as long as
Okay.
you're not exceeding the rating of the valve, you're okay in that situation, because
Okay.
as soon as your solenoid opens, all that pressure's gonna be gone. Anyway.
Sure, sure. Um, the next question then has to do with the 6-inch flow control system. This question came in. When I removed power from the solenoid valve, it's taking a little while, and we don't really determine what a little while is here. It's just kind of a general little while. They think it's too slow for to close the flow control valve. Is there anything that I can do to speed up this process? But before we go there, what could cause that? What would cause that to happen?
Well, what causes it to happen and kind of the slower reaction for shutting it down, it's based upon the size of the valve that we have. So when we look at the size of the valve, you have your volume of your priming chamber.
Right.
And the priming line coming in has a small restricted orifice on it.
Okay.
So when we open our solenoid valve and we open the flow control valve, we're dumping that prime water off to the drain.
Right.
So now when we de-energize the solenoid valve and it closes, we have our priming line open. Another good reason why we leave the priming line
Yeah.
open, so that when we de-energize the solenoid valve, the prime pressure starts to reestablish through that restricted orifice. And the larger the valve, the longer it's going to take to refill that volume in the chamber. And then
Okay.
with the help of the spring, it'll push the clapper back down onto the seat.
Okay.
A rule of thumb, it really depends upon what your water pressure is, and this can vary, but a 4-inch valve could take 30 seconds after you de-energize the solenoid valve to shut down. Once we get into a 6-inch valve, it could take 2 minutes. And even with the 8-inch valve, now we have a much larger volume we have to refill. It could take up to 5 minutes for that valve to
Okay.
close.
Well, so when we say it, when he's saying it's taking a little while, this is only a matter of minutes, really, that it's taking. Just seems like a long time. So, is there anything they can do to speed the process up? That was the original question. I just kind of added on what would cause it. But is there anything they can do to speed it up? And why would it matter? Or just be patient.
It depends on the application, where if you want that valve to shut down almost instantly
Right.
once you cut the power off to the solenoid valve, we have our pressure regulating systems. So our pressure regulating systems, once you put the pressure regulating trim on there with the C2 pilot regulating valve, what it's going to do is it's going to shut down almost instantly once we de-energize the solenoid valve.
Okay.
Now, the reason it does it so much faster in that situation is because, I was explaining on the flow control trim, the standard flow control trim, we dump that priming water off to the drain. So we have to refill that entire volume. With the pressure regulating system, what it does is we actually release that prime water into the C2 pilot regulating valve. So we're keeping most of that volume inside the priming chamber. Because for the pressure regulation, you only want to open the priming chamber so far, and you kind of pinch the water supply,
Right.
and that's how we reduce the pressure
Okay.
to the outlet. So now when we de-energize that solenoid valve by hitting an abort switch or by flipping the switch and de-energizing the solenoid valve, now it's almost going to shut instantly because we still have that volume of water in the priming chamber.
Okay, so you've never really released all the water out of the
Right,
in that case.
And one thing to keep in mind with that, if you're going to use that, you have to at least have a 20 PSI reduction for the C2 pilot regulating valve to operate properly. So you get the advantage of the valve shutting down right away, but you do have to take into consideration that you're going to have to lose 20 PSI from the inlet to the outlet for that C2 pilot regulating valve in that situation.
Okay. All right, question number 5 then becomes, if I open an emergency release valve to trip the system and then close that emergency release valve, will the flow control valve still reset itself?
Well, in that situation, just like you would with the solenoid valve, the solenoid valve opening, then de-energizing it, it allows the prime water to reestablish in the priming chamber.
Sure.
With the emergency release, it's going to do the same thing. So you open the door, you pull the emergency release, you dump your prime water out of the priming chamber. So now when you close it, we still have our priming line open in that situation. So now when we go and close the emergency release, your prime pressure is going to start to reestablish. And like we discussed earlier, depending on the size of the valve,
Right.
Once it refills that priming chamber volume with the help of the spring, it's going to shut the valve down.
Okay. Good. Why doesn't flow control trim have a pressure-operated relief valve, or PORV, installed on it, like the D3 or the D4 PORVs? Why aren't they there?
Well, the pressure operated relief valve is used on the trim on our standard deluge and pre-action systems. And what it does is once the valve operates, the PORV is going to continuously vent that prime pressure. Once again, we go back to leaving the priming valve open, so we're still supplying prime water into the trim with that priming valve open, even when the valve's activated. So now the PORV is going to vent that prime pressure off to the drain. And to be able to close the PORV, somebody physically has to walk up to the valve, close your water supply control valve, and drain the pressure off of the sensing side of the PORV. So with our flow control systems, the purpose behind them is that we can reset them from a remote location, and we don't have to be right there in front of the valve.
Right.
So if we had the PORV, since the only way you can get it to close is to physically come and drain the pressure off of it, it wouldn't work in that situation. You wouldn't be able to just hit a button and be able to close down the system, which is the intended purpose of the flow control systems.
Okay. This next question states that I need to select a flow control valve, but I don't know what the differences are between the models J1 and the H1 flow control valves. Can you help me out? What's the difference?
Well, when we look at the two styles that we offer for our flow control valves, we have the J1 flow control valve, which is your straight through style.
Yep.
And then we have the H1 flow control valve, which is your angle style.
These are being shown right here.
Yep,
right?
yep. You can see the angle style on there is going to be where the inlet comes in, and then it makes the 90-degree turn and goes to the outlet, where the J1's going to be straight through. Now, as to which one you decide to use, it's going to be based upon if maybe you have a situation where you don't have a lot of room, or you need to install the valve in a certain configuration to be able to fit it into the space that's required for the installation. So with the Model J1 flow control valve, you can install it vertically in the flow up direction, or horizontally with the cover facing up.
Okay.
So it has two possible installation orientations.
All right.
With the Model H flow control valve, you can install that in any configuration. So if you had a odd supply coming in where, say you had a situation where you might have to install it upside down, you could with the Model H1 flow control valve, but you wouldn't be able to do that with the Model J1. So looking at the installation orientation, that's really going to drive which one you would select.
So orientation and spacing too, I mean, the amount of space you might have in that, would that drive it? Would that be a consideration?
Definitely, because with the Model J1, if your underground's coming stubbed in up through the ground, you can just go straight up with the Model J1.
Right.
Whereas if you use the ankle style, you're going to have to come out of it, and then you're going to have to come out a little bit, use an elbow, and then go up. So it's going to take up a little bit more space than your J1 would.
Okay, great. Let's see, next question then becomes, why are the flow control valves, these flow control valves, painted red, and I got some of them that are painted black. It's not really a painting on, it's not painted that color, it's actually coated, isn't it? It's a halar coating, right? So
yeah, that's what we're looking at. Anytime you see any of our valves, even beyond the flow control valve, if we look at the deluge valves as well, if you see them red, that just means it's our red paint that's being used on it. But the black ones are the ones that have the halar coating, as you mentioned, and that's our corrosion-resistant finish that we put on them. So anytime you would have salt water, for example, or any type of environment that could be corrosive to the valve, you're going to want to use the halar-coated valve. And it's called the J2 or the H2 in that situation. So the J1 and H1 are your red valves, J2 and the H2 are the halar-coated valves.
Okay.
Another application where you can see it used would be if you have a foam system where you're using flow control valves. The smaller valve that's holding back the foam concentrate, because foam concentrate can be corrosive. So you use a halar coated valve, and we call it the concentrate control valve, and it's a smaller flow control valve that can be used to hold back the foam concentrate
Right.
until it's ready to go into the proportioner and mix with the main water valve once they both open simultaneously.
Right.
So you'll always see the small concentrate control valve as a halar coated valve
Is that
on
right?
those types of systems.
Okay. I have a large flow control system with a change in piping direction shortly after the outlet of the valve. So this person is concerned with water hammer coming out of the valve, system operates, slams into the corner of as it's changing directions. So what it can be done to prevent that water hammer?
Okay, as we have shown on the screen behind us here, we have our speed control assembly.
Mm-hmm.
The speed control assembly can be used either with the H1 flow control valve or the J1 flow control valve.
Okay.
And what the speed control assembly has in it is it has a needle valve. So now when the valve opens, instead of having a 1/2-inch pipe leading out of the priming chamber to dump the water out and allow the valve to open quickly, now we're regulating how quickly that prime water is being released from the valve, and we're slowing it down so we get more of a slower opening of the valve, and we don't get that sudden rush of water coming out that could create that water hammer, as you mentioned, with that sudden change in direction.
So, go ahead.
I was just gonna say, so the speed control assembly would be what we offer to prevent that from happening.
Okay, so, but when we're looking at speed control now, I mean, one of the things we're really concerned about is getting water to the, to the sprinklers, water flowing at the appropriate pressure in the sprinklers, things like that.
Sure.
So is this a problem? I mean, what are we talking about? It's slowing it down. We're not talking
No,
about
it's
minutes. We're really,
right. It's
yeah.
just opening more at a gradual pace than
Okay.
instantly opening
Instant.
up and allowing the full flow to come through.
Sure.
So it's just opening at a more gradual.
Okay, all right,
Speed.
that's what that's what I was kind of looking for, is we're not talking a long time. It's kind of like, what was the one with the approved, the flow control valve, the other question about how long does this take? And you're just like, no, not a long time, a little bit of patience, but this time we're slowing it down a little bit. We've seen this question, we've worked with this question before. Why do Viking flow control valves have additional connections that are not used in this particular, in a particular system or in my system? So why do we have that?
Well, when we look at the ports that are on the flow control valves, we have the same ports on both sides of the valve. So for one, if you had an installation we were talking about, if you have a small confined space, or
Yeah.
depending upon where the water supply comes in, maybe you can't put the trim on the side of the valve as shown. Well, since they're the exact same ports on both sides, you could actually flip the trim over to the other side of the valve if
Okay.
you needed it for that type of situation.
Okay.
Plus, also, we'll see other ports on there. For example, on the cover, there's 3 ports on the cover itself.
Yeah.
Well, you don't use all 3 of those ports. However, the cover, if you have the J1 flow control valve and you're installing it in the vertical position,
Yeah.
you're going to be connecting to the top port on the priming chamber.
Okay.
If you're installing it in the horizontal position with the cover up, you would actually be connecting to the bottom port on the priming chamber.
Oh, okay.
And now this same cover is used on the Model H1 flow control valve, the angle style as well. So with the H1 flow control valve, we'd actually be connecting to the middle port on the priming chamber. So that's
Okay.
why you can see multiple ports that you're not always using,
Right.
because not only for the priming connections, but different systems are going to use different ports on the valve as well.
Okay. Now, just as a freebie here, is there a reason why you would, for in the vertical position, you got it on the top, but on the horizontal, is there an advantage? Is there a reason why that you have that coming in at the bottom on a horizontal installation?
Yeah, it helps so you don't get air trapped in there.
Oh, okay.
So when you're filling it up, you get less air trapped in there, because we want to fill the priming chamber with water.
Right.
You never want to fill it with compressed air to begin with, but I'm talking about a little bit of trapped air in there.
Okay.
It just helps prevent that from building up.
Oh, okay. All right. Well, that's the end of those 10 questions, and so we're come to the end of our Tech Talks on flow control systems. I'm Jim Legg. This has been Shaun Kramer. If you have any questions that you need answered right away, you can certainly contact our technical services department, our technical services team what's the number, Shaun?
Our toll-free number is 877-384-5464, or you can visit our website at www.vikinggroupinc.com.
Great. Thanks, Shaun. That's the end of this episode. We'll see you on the next Tech Talks. Thanks.